All right, we'll talk about the monthly space news. Roughly the last month is our last meeting. It's now the 10th of September. In the highlights of this, give you a little overview of what's coming in the news. Artemis 1, which of course is the program for getting the United States back to the moon, had scheduled Artemis 1 launch today. It's been delayed, and a couple of reasons for that. Hydrogen, and we'll talk a little bit about the fact that they're using hydrogen for propellant. There's some pluses and minuses to that. The minuses are showing up right now. Also, one of the secondary payloads, or ride shares as they're called, was also going to be launched at the same time, which was kind of interesting because this is going out to visit a small asteroid using a solar sail, which you don't see every day. And speaking of asteroids, we'll talk a little bit about the DART mission. It's going to be crashing into an asteroid, and that's a good thing. And we'll talk a little bit about the lunar spacesuits and the fact that people are now advertising you're going to be able to get cell phone service from the satellites directly to your cell phone, not on an Iridium phone, but an actual ordinary cell phone that you carry around with you. And we'll talk a little bit about recent launches. Okay, so Artemis launch being scrubbed. And I say that again because it's not the first time. So keep in mind, this is supposed to be a 42-day mission going essentially around the moon a few times. No crew, but it's practice for the next time when they'll do the same thing, but with people in it. And there were two scrubs recently, scrubs meaning delays. The first time, they had a small hydrogen leak, but they turned out that wasn't really a problem. They could solve that. But there was a much bigger problem, and that's that normally hydrogen is used to cool down the engines before they start. The reason is it's using liquid hydrogen, which is very, very cold, and it would be quite shocked to hit it all at once. So instead, they cool it down gradually with a called bleed valve, a small flow. Those engines were not cooling down. One in particular was not cooling down enough. So they had to halt everything. It turned out that was really just a sensor problem. They finally concluded that. But the second one was much more serious. They had a big hydrogen leak. And this is in a quick disconnect fuel line. So normally what happens is the rocket's sitting there in the pad, and right at the very last second, they rip that connector off, and then the thing can take off. And that was leaking pretty badly. And this has been a common problem with hydrogen systems for a long time. So it's not the first time this kind of thing has happened. Now, why did it happen, though? That they still don't really have a good analysis of. What has been suggested is that there was a sequence of valves that had to be flipped on and off during the normal startup sequence. And they did detect that they really had overpressured one section of this thing, in particular, right where that seal is. So it might actually be due to human error. Now, people that have worked in other industries immediately ask, well, why don't they just automate that? So you can override an automation, but normally things like that ought to be done automatically so the human error doesn't creep in. I haven't heard a good answer on why not. But anyway, because of all the delays, that led to secondary concerns. What happens, you have a lot of batteries on this thing, and they're rechargeable, but you can't necessarily recharge them while they're sitting on the pad. They're not set up for that. The big and most important one is the flight termination system. Now, this is the system so that if the rocket starts to take off and then something goes badly wrong, they can blow it up before it gets out, over a populated area or something. So that's a requirement, and that Space Force is now in charge of enforcing that. Now, in addition to the main payload, which of course is the Orion space capsule, shown here on the right-hand side, there's also some smaller CubeSats that are the size of shoeboxes, and they are up there just below the Orion capsule and its service module. What happens is when the rocket gets up high enough, that opens up, and then they can launch its secondary payloads. And those have been sitting there for a year now in the vehicle assembly building for a long time. Even in the vehicle assembly building, half of those things can't be recharged. They just don't have facilities to do it. The others could be. In the case of at least one of them, they didn't actually do the recharging. So they've been sitting there for years. So the longer this drags on, the more and more of these secondary payloads are not going to be able to work. Once they're up in space and with the solar arrays unfurled, then they can charge themselves back up. But the question is, will they have enough power to unfurl the solar arrays? And so that's uncertain at this point, but they've all been sitting there for quite a while. So now anyway, there's delays. The big question is how to fix them. So first of all, for the hydrogen leak, that's a quick disconnect. They want to fix that on the pad. But then the question is, how do you test it?
You can't test that back in the vehicle assembly building. They don't even have hydrogen supplied to that building. That would be too risky. If any hydrogen were released inside the building, you risk having a flammable or explosive mixture.
So they have to do that on the pad, and that's what they're going to do. Even as we speak, they're working on it. They may have it fixed by now. And so they are testing They're going to have what's called a tanking test where they fill the whole thing up with fuel. That's coming in mid-September now. But the remaining question is still, what about this flight termination system? Its battery is only certified nominally for 20 days, and they already had exceeded that. They had gotten a recertification where they said, well, okay, we think it's probably still okay. They apparently can't actually just measure how much charge is left in it. But the question is going to be, can they put that off? They don't have to go back to the vehicle assembly building. If they can just get recertified, everybody says, okay, we believe the battery is still good on this thing. It's a big deal to go back to the vehicle assembly building. It takes a while to get there. There's also a lot of vibration and everything. And the SLS rocket itself is only certified for a certain number of those trips back and forth between the launch pad and building. So they don't want to do that any more often than they have to. So if they get this certification where everybody says, okay, we believe the battery is okay, then they'll go ahead and launch toward the end of September. If not, it'll have to be delayed until October because they need extra time to get the thing back to the assembly building, do the work that's necessary, and bring it back.
One thing to point out is they've never really fully fueled the rocket ever.
First and second stages, because they never made it far enough into the countdown to get to that point. So that's why they're doing this so-called tanking test coming up in mid-September. So I think most people here are probably familiar with this rocket. I used the same pictures that I used in previous months. You know, you got the SLS, which stands for Space Launch System. That's the rocket on the left-hand side. It's mostly a lot of parts from the space shuttle, including the engines. And the boosters are slightly extended versions of what they had. The main body is pretty much what the giant fuel tank was that came with the shuttle. So they inherited a lot of the pluses and minuses of the shuttle program. And let's talk about that, because the big issue is hydrogen. The other possible fuels are things like hydrazine, which was used a long time ago and is still used. It's extremely powerful, but it's extremely toxic as well. And so you don't want to use that as much as possible. Some of the newer boosters are using methane and oxygen is the combination. You see that on the SpaceX Starship. The older Falcon 9, that actually uses kerosene. But anyway, hydrogen is an old standard. They've used that ever since the 1950s. So you could say we have a lot of experience with it. Unfortunately, the experience hasn't been completely good, but there are a lot of reasons why people like hydrogen. First of all, it's extremely lightweight. Even when you have to store it as a liquid, it's still very light. You store a lot more power with hydrogen than with anything else, really. There's ways of measuring the power that you get out of the combustion of hydrogen or any other fuel. Specific impulse is the particular one people home in on, and it has about the highest. So overall, from a weight standpoint and from how much you get out of a given amount of hydrogen, it's very, very efficient. So people like it for that. And a lot of upper stages, even in newer rockets, are still using that. And looking ahead, there's some possible benefits to using hydrogen and oxygen as your propellants. The big one would be if you want to mine ice on the moon, you get the ice, you can immediately just use electrolysis to get hydrogen and oxygen. So right there, there is ice that's available on the moon. You know that you could generate fuel there then for use in exploring the solar system. That's still a lot cheaper than bringing it up from Earth, essentially. So there are some potential benefits there. Now, you can also do in situ generation of fuel with other fuels, methane, and that's why Starship is going for that. There's additional reactions. You need something like CO2, and that's great on Mars. There's a lot of carbon dioxide. The atmosphere there is mostly carbon dioxide. So there's plenty of carbon atoms, which you need to make the methane. And so there are reactions you can use for that. But the moon, that's more of a problem. There's not as much carbon on the moon in any of the chemical compounds that are there. There probably is some tied up in some chemical compounds in the water, frozen, the water that's at the poles. So there may or may not be enough there. But anyway, so I would say that on the pro side, though, certainly it's as simple as simply just to electrolyze water to get hydrogen and oxygen. Now, the cons, the biggest single one is simply hydrogen is an extremely small molecule, sort of the smallest you can have. And as a result, you get leaks. Any kind of seal, such as what happened with the rocket that they're trying to launch on right now, you can have leaks. Even the pores that are in wells can leak. And for that matter, a lot of metals themselves are somewhat porous to hydrogen. It's just so small it can slip right through. So there's been a history of leak problems. For instance, the entire space shuttle fleet was grounded for 6 months just trying to track leaks at one point. And it was not unusual for there to be at least one scrub with almost any space shuttle mission. So it's been kind of a background problem for a long time. Now, people are handling it. I mean, for instance, the New Shepard rocket by Blue Origin, that's going to be the upper stage of their future big rockets, but the small ones are just using for suborbital flights. Now, that's based on hydrogen. But the thing is, apparently, it's not that bad if you're only trying to deal with small quantities of it. The real problems are when you scale up to a giant rocket like this one. Okay, so the second major con for this is that hydrogen, to liquefy it and store it, is extremely cold. I have that, yeah, minus 423 degrees. That's pretty darn cold. It's hard to get it to that, expensive to get it to that. And it's hard to keep it. There's a bunch of problems with it. One is it does expand quite rapidly when it heats up. So if it ever starts to heat up, you run the risk of really overpressuring or exploding things. It's very volatile. It vaporizes quite easily. So as a result, you need a lot of insulation. And that's both on any tank you have on land, and it's also true for the vehicle itself, for the rocket. So that means you have extra space and weight just to have extra insulation to handle that. You don't run into that with the methane, for instance, anywhere near as much. And you also have to have venting. Because it is so dangerous, you have to be able to vent it to keep the pressure from going too high. And again, that adds extra complexity. And then there's a side effect just because it is so cold. For instance, when you fill up the tank on the SLS rocket, it actually shrinks 6 inches. I mean, it's that dramatic of a thing. And what that says is that every coupling has to be kind of like accordion kind of a thing. There's a lot of stresses and there's all kinds of extra complexity to deal with the fact that the shrinkage, the changes are so great when you introduce fuel where you don't have it before. Another big problem with hydrogen is it's extremely flammable over a very wide range of air to hydrogen. Almost any amount of hydrogen leaking presents a flame hazard. And that actually is the final reason that they had to do the second scrub they did. They're willing to tolerate up to maybe 3 or 4% hydrogen in the air right near it. But any much more than that, you're in trouble. And they were like 3 or 4 times that. It was quite a bit more. So they were very seriously worried about that. And the other thing about hydrogen, when it burns, the flame is practically invisible. And so you might not even realize you've got a fire. No, you can. It kind of depends on air and other things that are present, but it's very hard. People that worked around refineries probably know this because where they have hydrogen, there's a few places where hydrogen is used for treating fuels, typically to get rid of sulfur. They warn you, watch out. Any of those hydrogen lines, if there was a leak and they were on fire, you might not realize it. So you don't want to get too close to them. And then the final issue is that metals get brittle, partly because they're cold and partly because the chemical composition changes a little bit as well. So those are kind of some of the trade-offs. Now, those were essentially inherited because you might say the SLS was kind of designed by Congress indirectly, in that part of the legal legislation that funded this in the beginning was they had to reuse the shuttle equipment. And it was really aimed at reusing the contractors. They wanted to keep them all in business because everybody had jobs in their districts, and they wanted to make sure that there was no loss of jobs. So they said, actually, in the law, they said you had to reuse the equipment. So they sort of made this design decision. I'm not saying it's necessarily an awful one, just that NASA kind of had his hands tied up, so they didn't really have any choice. Okay, talking about the secondary payloads, there's one called the Near Earth Asteroid Scout. And this is a small one. And again, this is the size of a shoebox. One of the 10 is going up with the Artemis 1 mission. Its mission is to explore small asteroids. Nobody has really gone to look at the small one. And so this is a shoebox-sized thing, but it's going to have a giant solar sail. By giant, I mean 925 square feet. It's about the size of a tennis court. In this picture here, the little thing in the center, that's the basic size of the thing with the solar cells extended. Everything else there is just a sail, some kind of polymer, like a mylar kind of a thing coated with aluminum. Now, this is a ride share, meaning it's a secondary payload. That's pretty common in the rocket business these days, but most rockets are really just going up for satellites going around Earth. This is an unusual opportunity. This is something that actually is going out even beyond the moon and coming back. But if you choose not to, this is a great time to do it. So most of the missions that were going up with Artemis 1 on these secondary payloads were all ones that had either a lunar focus or, in this case, the asteroids, because they had this great boost. You got a good start. Now, anyway, when this thing goes, its first visit is going to be an asteroid that's about the size of a school bus. It'll get there in 2023. And it'll fly by at about 68 miles an hour, which sounds like a lot, but that's actually about the slowest anybody's ever gone, except for those cases where they've landed to take samples. But most asteroids, they don't do that. So that's pretty good. The main instrument is really just a 14 megapixel camera, but they're going to do a lot with that. They're going to figure out the compositions, looking at the spectrum with different filters or something. They'll figure out the rotation, and they'll do quite a bit with it. So even just having a camera does a lot. Okay, well, as long as we're talking about asteroids, there is another one where we're going to be crashing into an asteroid on September 26th. And as I said, that's a good thing because it's part of a test. The mission was launched back in November of 2021, called for double asteroid redirection test. It's a double asteroid because we're going to a binary pair of asteroids here, Didymos and Dimorphos. They're shown in the picture here. You might think of Dimorphos as being a moon. Dimorphos essentially circles the other one. And that's the one they're going to hit. That way it's easier to measure it. For instance, one way to measure it is the orbital period of Dimorphos around Didymos will change. And it's very easy to see that. You can't really separate these two with a telescope. But what you can do is you can see when Dimorphos comes in between the bigger asteroid and you, then the light's dimmer. So the same way you detect planets around stars. And so they'll simply be able to measure the period. And that's one way they can measure the effect of this thing slamming into Dimorphos. So it's about 1,100-pound craft. It'll be going about 15,000 miles an hour, and they'll just basically smash into it. Now, they will release a small CubeSat, a little bit bigger than a shoebox, made in Italy. It's going to record the collision. They release it, I don't know, a day or something before they get there. So they'll record that. And then there's a follow-up mission called Hera, which is run by the European Space Agency. And they're going to go up 4 years later, can visit this and try to analyze, well, what happened, how crater was formed, and all this. So they'll do more extensive study later on. So there'll be plenty of follow-up on this one. Anyway, this was launched back in November on a Falcon 9. That was probably the first interplanetary use of a Falcon 9. They've had some since then, I think, as well. Now, this particular drawing here, they're showing it with a fanciful view of an ion engine here in the back. The reality is they do have that ion engine, but that was mainly there for a test. It was a brand new design, and they wanted to be able to try it out for a long period of time. It has relatively minor impact in this mission. Getting the thing to the asteroid pretty much was handled by the Falcon 9. There are some very late maneuvers when you get very, very close to this pair of asteroids, and they have separate thrusters for that. The ion engines are good for long run at a low thrust, not for quick maneuvers. So the quick maneuvers they want at the end, they're still using conventional thrusters. And keep in mind, this is September 26th, so by the next meeting, we should know something about what happened. Okay, and then we get into spacesuits. We've talked about this in some of the previous meetings. It might have been on the critical path for the Artemis lunar landing, certainly back when it was hoped to be around 2024 or so, because there was an audit report that was issued late last year saying they're not going to be ready. There have been programs that have been going on with NASA for quite a while, and they simply just weren't ready. And independent of that, the spacesuit that they were using in the space station, they were getting water in the helmets, and they've had several fairly serious instances of that. There was ones around March of this year. They finally brought back that particular spacesuit for analysis. You don't get very many missions where you get to come back from the space station, because if you use a Cygnus cargo craft, that just basically burns up in the atmosphere. It's only the Cargo Dragon from SpaceX that brings back the cargo. Well, in the old days, the space shuttle did that, but now it's only the Cargo Dragon. So they finally had one coming back, so now they can look at that. So they've had trouble with spacesuits in any case. And so NASA decided they better start a new commercial spacesuit program. And by commercial, we're meaning following more the mold of what they were doing in some of the other more recent programs, where you set up a couple of vendors and you get them to compete against each other and bid, but you give them high-level requirements. It has to support people of a range of sizes, supply air for so long, and that sort of thing. But leave the design really more up to them. And so they did that. They narrowed down the choices to Axiom, which is a Houston company, and Collins Aerospace, which is actually building the spacesuits also in Houston. Back in June, they decided that. It turned out, we found out later, they were the only two people to bid on the contract. Nobody else even wanted to bid on it, which is a little surprising. SpaceX, Elon Musk had made some comments about, well, if nobody else can do that, we'll do it. Well, he decided that's distracting. We'll let other people worry about this one. So they did. Well, it turned out Axiom got the first contract. But the overall program is pretty big. It's like $1.5 billion or something. But this is just a release, one small contract specifically to build some spacesuits for the Artemis 3 lunar landing. That's the first one. And they got that. Both companies will be eligible for future awards, and I'm sure they'll be getting some, because they haven't awarded anything for space station spacesuits yet. Okay, and then one that may have surprised some people is that there's now talk that you may be able to get cell phone service on your cell phone, not an Iridium cell phone, but just regular old cell phones. I modified this a little bit, saying, well, sort of, because there's some qualifiers that come with this. But let's back up a little bit. Iridium did prove that you can have a constellation of satellites that will provide service and actually good audio phone calls. They started that back in 1998. They made it work. Worldwide service. So that's been proven, but this is not your cell phone. This is a specialized cell phone, used especially by spies and drug dealers and so on. They're the best. But they use special frequencies. It's not the same frequencies that are used on your phone. It had kind of a clunky antenna, which you had to kind of point up at the sky. It had to have a very heavy battery to deal with the extra power that was needed to reach, all the way out to low Earth orbit, 200 or 300 miles, somewhere in that range. And it pretty much needed line of sight. You had to pretty much have a direct view of the satellite passing overhead. You only see one particular satellite about 7 minutes as it goes by you, but then another one picks it up. So there's always one in view. That's why they have as many as they do. So there's now a whole new wave of activity, though, where they want to do this with regular cell phones. And nobody would have thought this was possible, but it turns out it is. Essentially what they're doing, just think of it as putting cell phone towers in the sky. The big thing, though, is because it's further away, you just have to make the antennas a lot bigger. That's one of the biggest single changes you have to make. You make the antennas a lot bigger. You can transmit with low power. The Voyager spacecraft, which is out for 14 billion miles from Earth, still is transmitting with not very much power all the way back to Earth. You just have to have a big antenna to pick it up. There's other parts too. There's built-in limits that, for instance, normally a cell phone tower would just refuse service to something when it figures out that it's more than like 20 kilometers away, something like that. So all these new systems, they have to kind of lie to the cell phones. They do the calculation of how far the cell phones are away. They just lie. And they also have to compensate. There's a Doppler shift effect. The frequencies change because you're flying over so fast. There's all kinds of things like that, but that trickery can be done, and it's been proven that it will work. Here's the thing, though. All the new entrants, we'll talk about who they are, they're essentially filling in gaps in existing service. You know, if you're in a national park, a lot of times you just don't have any coverage. And there may be 10, 15, maybe even 20% of the U.S., you know, over lakes and big lakes and things just don't even have service. And that's really the target here for now, at least within the U.S. Now, obviously, there's probably a bigger market overseas, but they're all starting in the U.S. They're not really expecting to compete in any normal, well-served area. It's going to be more expensive than just, you know, having your little cell phone tower out at the corner there. But that's okay. They figure we're going for the areas that are not served, including rural areas where it might cost a lot of money to even get the basic infrastructure out there. And by basic infrastructure, you can kind of see some of this on the picture on the left here. This is one of the companies, Link Global. They're saying, you know, use your cell phone whenever you're within reach of a normal cell phone tower, you just use it. But if you're out of reach, you know, you're down in a crater in a mountain area or something, then it just switches over to one of these towers in the sky. That doesn't show the whole picture. That shows the cell phone communicating with it. But then there's, well, how does that flying tower communicate? That's called backhaul service, which connects you up to the rest of the network. And so that has to be handled too. So that says you have to have a lot of ground stations to cover. And that's why this kind of coverage, this kind of approach means you do have to have a lot of ground stations everywhere. And they will. So there's two companies I highlight here, Link Global and AST Space Mobile. They really started this particular process going. But now SpaceX and Apple also have announced some programs in this area. But really, the first two companies are further along. We'll talk a little bit about them. So Link Global, they've actually proved that you can do text messaging from space. They proved that back in 2020. Then they launched some test satellites, and they're all gone by now. But the first mass producible satellite was back in 2021, and they're launching a few more in November. They have an 11 square foot antenna, which actually is not that big, but it's a heck of a lot bigger than the ones that are, you know, like this high that you see out on your normal cell phone tower. They are saying that they're going to start text services before the end of the year, but it's going to be intermittent. There aren't enough satellites yet. So something will go by, you have to catch it at just the right time. So maybe once an hour, you might be able to send a text message. But still, if you're out hiking in a rural area, in a wilderness area, that's a big improvement over having no communications whatsoever. So there is a definite value to that. It's just that they have to start off with not a lot of service and only text. It's very low bandwidth. But they're saying by 2025, they hope to at least have global text and low-speed data by 2025. It'll take thousands of satellites to really get more, in particular for continuous talk, but at least they're going that direction. That's their approach. Now, AST Space Mobile, that Texas company, they're sending up their prototype satellite. Actually, I think it's tonight. It's in September. It has a much bigger antenna, 693 square feet. If you take the square root of that, it's about 26 by 26 feet. The picture here on the left-hand side. Some astronomers are concerned about that. That's a much bigger surface area than the Starlink satellites have. They've been complaining about that. This will be a lot bigger. Sky and Telescope magazine said probably to be one of the brightest objects in the sky. I can't believe it'll be as bright as the space station, which is huge, but the thing is, it's pretty reflective. So what these satellites have, you look at the lower left-hand corner picture here, on the back side, those are solar cells. And then the front side is antennas. And what will happen is, as the thing swings around, the sun will reflect off of it. You know, you may get big flashes. We'll see. Anyway, they're expecting to put up their commercial satellites. They just delayed due to some kind of supply chain issues till late 2023. But there are about 110 satellites in their plan. Now, the thing about both of these companies is they already have agreements with mobile network operators now. This particular company already has backing from Vodafone, Rakuten, which is a Japanese company, Orange, which is big in Europe, and then equipment makers like Nokia and American Tower, who supplies the backhaul services. American Tower, they're the people that do your cell phone towers now. They're a huge player in that. So they have good backing, and they've got all the players in place to make this happen. Yeah.
So good thing is that you get home service anywhere.
bandwidth end of ground-based astronomy. That's the worst case scenario. So there are definitely astronomers that are bringing that up. It may turn out it's not as bad. And the thing is, these people have made no particular effort to do anything about that, unlike SpaceX and Starlink, where at least they made some efforts to do some codings and things. And, there may be some movement there. But yeah, in the long run, there's going to be issues for people with ground-based astronomy. That's just inevitable. I mean, there's so many more satellites going up. Okay, so now the big players, SpaceX, they had a big to-do down at Boca Chica where they announced their link up with T-Mobile. They're planning on beta testing the end of 2023. So they're having an antenna not as big as the one we just talked about, of 270 square feet. If you take the square root of that says about a 16 by 16 foot antenna, not quite as big as the one from AST. And they've emphasized this is limited bandwidth. One satellite will only handle 2 to 4 megabits per second. That sounds great, but that's for everybody in the area that entire satellite is handling. Maybe they can handle a couple thousand calls, or what they prefer is 100,000 text. Text messages are easy. It's low bandwidth. You can tolerate delays. Can't really tolerate that on a phone call. So they're saying text messages and pictures and voice and data will come at some later date. Now, Apple also just made an announcement just a couple of days ago. So they're saying that you can have an emergency SOS. If you have an iPhone 14, when you don't have terrestrial network coverage, you'll be able to make an emergency call. And it's another one of those cases where you might have to wait a little bit. And they're going to give you an app, and the app look kind of like this, where you hold it and they'll say, point the phone this way so you get connectivity. You do have to have direct line of sight to the sky. So all these things are not going to be as convenient as just using your phone without thinking about it. But compared to having nothing at all, you fell into a creek or something and didn't get your phone too soaked, you might be able to get rescued by somebody. In typical low Earth orbit, you have about a 7-minute view of any given satellite. That's more or less how it works out. So they've tied in with Globalstar, which is another one of these companies that's handling communication satellites. Turns out Apple will be their biggest customer now. And they have about 40
satellites,
and Apple's investing in them to help them build more. Okay, we're up to the point now where we'll talk about launches since the last meeting, meaning launches that are going to orbit or beyond. How many people think we had recently? Okay, you're going to say 100,000. I know. 100,000. Yeah, you're too high. I'm glad to hear that optimism. Who thinks there were at least 12? Especially given last month where we had 25 or whatever it was. Well, actually, I hate to disappoint you, but it was only 11. It was a slow month. What can I say? And almost all of it's pretty routine kind of stuff. A whole lot of Starlink satellite launches from SpaceX for internet service, and a whole lot of Chinese launches, mostly for spy satellites. So that's pretty much it. And one that I showed here, this Ariane 5. This is near the end of their life cycle. They're not making these rockets anymore. There will only be 3 of those left. That's the European Space Agency. That was their heavy lift vehicle. And there's 3 of those left. They just used up the 4th one here. So actually, there's not that much to talk about. Other than one that was kind of interesting was one of the Starlink launches, launched some satellites, and they launched a Boeing rideshare for testing out broadband communications from space. So basically, they're providing the rocket to get up for a competitor, potential future competitor. So that kind of thing happens all the time, actually. A couple of months ago, we talked about Astra, small rocket launch provider, and they had a failure, and so all the satellites were lost. Well, some of the satellites that were on that rocket were actually by a company called Swarm, which we talked about a long time ago. They're the ones that are doing very, very low bandwidth satellite-based communications for Internet of Things, but they charge $5 a month, so it's an incredible bargain. And their satellites are ham sandwich size. Well, it turns out Swarm was bought by SpaceX. So actually, this Astra crash was a failure for SpaceX, but it was a minor one. But just kind of goes to show you that when you're a launch provider, you're in a lot of businesses and you're often even supporting your competitors. OneWeb being an example of that. Starlink is competing with a company called OneWeb. And nonetheless, they would be happy to launch the satellites.
Going back to the Ariane 5 discussion, Doug Hall commented that in a perfect world, they would have Ariane 6 ready before they stop making the Ariane 5 rocket. But Ariane 6 is not ready yet.
You might think that. Yeah, the Ariane 6 is coming along. They say next year. But the thing is, there are 3 left. That will take them, at the current demand, that will take them through next year. So they expect to have the next one ready. Now, the Ariane 6, of course, you could say is kind of obsolete the day it comes out. It's still a disposable rocket.
Doug is wondering how the other players are doing in producing a reusable rocket.
Right now, it's still only SpaceX. Well, you have Rocket Labs for the small launches with their Electron rocket. They caught one in the helicopter. They ended up dropping it because they thought there was something wrong when there wasn't. But they're going to start at least catching them on helicopters again and big nets. But the next generation, the ones that are essentially competing with the Falcon 9, they will be reusable. Same is not true for relativity space. Relativity space, their original design was not reusable. I'm not sure, but now they said, well, that was really too small. They're going to make a bigger rocket, and that one will be. So they're coming. And there's the Vulcan rocket from United Launch Alliance. It'll have a Blue Origin engine, but what they said was most of the value is in the engine. So they'll try to recover the engine, but they haven't actually done much to even make that happen yet. So it remains to be seen. They will eventually do something. The Europeans are the worst because they actually went and complained. They said, we think SpaceX is probably giving away launches. They can't possibly be doing this at the low cost that they're charging. Well, of course they can, because they're reusing the rockets. It's not that hard to figure out.
There's a question about the viability of reusing equipment that's been dropped into the ocean because of saltwater corrosion.
Yeah, I think it may take more work, but that may be the initial plan for some of these rockets. The saltwater corrosion is an issue, but the Electron rocket that dropped, that one did drop into the ocean. And they recovered it, and they've test fired it, and it still works. So it can be done. I think it may take a little bit more work.
Doug mentioned seeing a spacecraft dropped into the ocean, and it had an inflatable skirt. The inflatable skirt absorbed the shock and also kept the salt water off of the equipment. So that's another possible way to get some reuse while avoiding saltwater corrosion.
It's not clear what will happen. For one thing, with this Project Kuiper from Amazon, they're going to be putting up thousands and thousands of satellites. They're putting a big load on all the incumbents. And so they're actually going to be forced into trying to reuse just to be able to have enough rockets to be able to do things, as well as do it at a cost that will bankrupt them. Okay, I think that's probably pretty much it. Ready to get into the featured speaker, Chris May. He's a flight controller and an instructor at Johnson Space Center, a musician on the side.